The power grid has one problem that no amount of money has fully solved. Renewable energy is intermittent. The wind stops, the sun goes down, and sometimes, during winter storms, during weeks of calm, it stays down for days. Engineers call this the duck curve. Lithium batteries can bridge a 4-hour gap. But what about a 4-day gap? A week? Bill Gates and a coalition of the world's most powerful energy investors have placed a $1 billion bet on the answer. And the answer is something so primitive, so cheap, so abundant, that it covers every bridge, every ship, every abandoned factory on Earth. Rust. This is Form Energy, and this is the iron air battery. The Lithium Illusion. Lithium-ion is extraordinary for phones and electric cars, but for the power grid, for storing gigawatt hours across days of low renewable generation, it has a problem that nobody wants to say out loud: cost. A lithium grid battery costs between $150 and $200 per kilowatt hour. That makes 4 hours of storage economically viable. Beyond 4 hours, the cost curve turns vertical. Storing 100 hours of grid power in lithium would cost more than the power plants that generated it. The grid does not need a better lithium battery. It needs a fundamentally different kind of storage, one built from materials that cost almost nothing. Form Energy's answer eliminates the cost problem entirely, but it does so by accepting a trade-off that critics say makes it unsuitable for most applications. We will get to that flaw. First, how does a battery made of rust actually generate electricity? The engineering. Reversible rusting. Inside the battery are iron pellets, ordinary iron, the same material in a bridge or a car door. During discharge, air flows in. Oxygen from the air reacts with the iron. The iron rusts. That rusting reaction releases electrons. Those electrons flow through a circuit. That is your electricity. The battery is literally rusting to power your city. During charging, the process reverses. Electricity flows back in. It breaks the rust apart, back into iron and oxygen. The oxygen leaves. The iron is ready to rust again. The materials: iron, water, air. Cost: $20 per kilowatt hour, 10 times cheaper than lithium. Duration: 100 hours. No degradation, no rare earth metals, no fire risk. Just iron, doing what iron has always done. But here's the detail that separates this from every other battery startup. ArcelorMittal, the largest steel company in the world, is not just an investor in Form Energy. They are manufacturing the batteries at a former steel plant in Weirton, West Virginia. A town built by steel, hollowed out when steel left, now building the batteries that could run the grid for days. The supply chain exists. The workforce exists. The factory exists. Form Energy did not have to build an industry from scratch. They walked into one that was waiting for a reason to come back. The Economics and the Gigafactory. Form Energy was founded in 2017 by Matteo Jaramillo, who led energy storage development at Tesla. The company has raised over $760 million. Bill Gates invested through Breakthrough Energy Ventures, the fund he created to back technologies capable of eliminating carbon emissions at scale. GE Vernova is a strategic partner, and ArcelorMittal, the company that produces more steel than any other in the world, saw enough in reversible rusting to commit both capital and manufacturing capacity. The levelized cost of storage is the number that matters in this industry. Iron air targets $20 per kilowatt hour. Lithium sits at $150 to $200. At that price difference, you can afford to build enough iron air storage to cover an entire region through a week of calm winter weather. The first commercial deployments are signed. Georgia Power, DTE Energy in Michigan. Over 10 gigawatt hours of confirmed orders. The rusting battery is a product. With $760 million raised, utility contracts signed, and the world's largest steel company building your product, you might wonder why every grid operator on Earth is not already ordering iron air storage. There is a reason, and it is a number that critics have used to argue this technology will never reach its potential. The flaw. Round-trip efficiency. Put 100 megawatts in, you get approximately 50 to 60 back. Lithium returns 90. That gap is real, and critics are right to point to it. Iron air cannot deliver rapid power bursts. It charges and discharges slowly. For frequency regulation, peak demand response, or any application where speed matters, iron-air is the wrong tool. But for the specific problem of long-duration seasonal storage, the duck curve problem, the week-long calm problem, the economics reverse entirely. When the energy going in comes from excess wind and solar that would otherwise be curtailed, it costs almost nothing. And when your storage medium costs $20 per kilowatt hour instead of $200, you can build enough of it to cover days of low generation. The efficiency loss becomes irrelevant when the marginal cost of the input energy is zero. Iron-air batteries will not power your electric car. They will not go in your home solar system. But for the specific problem the grid has never solved, storing energy across days and weeks of low renewable generation, they may be the most important technology currently in commercial production, built from materials that cost almost nothing, manufactured by workers in a town that steel built and left behind, backed by the most credible investors in clean energy. The chemistry is ancient. The problem it solves is the defining infrastructure challenge of our time. Long-duration storage is no longer science fiction. It is a product, and it is being built right now in West Virginia. The future of iron-air batteries. Form Energy's next phase is focused on moving from a promising startup to a major energy company. After successfully developing its iron-air battery technology, the company's priority is to expand production, complete more large-scale projects, and prove that its batteries can operate reliably under real-world conditions. The coming years will be critical as more utilities begin testing and adopting long-duration energy storage to support growing amounts of renewable energy. As electricity systems continue shifting toward wind and solar power, the demand for affordable energy storage is expected to increase. Form Energy plans to meet this demand by increasing manufacturing capacity, improving production efficiency, and making its batteries more cost-effective. Another important goal is expanding partnerships with utilities, energy companies, and manufacturers. Successful projects will help build confidence in the technology and encourage more organizations to invest in long-duration storage. As more installations are completed, Form Energy will gain valuable operating experience, allowing it to improve future battery systems and reduce costs even further. Looking ahead, the company is also expected to explore new markets and expand beyond its initial projects. Many countries are increasing renewable energy generation, creating a growing need for reliable storage that can provide electricity for several days when wind and solar production is low. Rather than replacing existing battery technologies, its goal is to provide a solution for long-duration energy storage where traditional batteries become too expensive. If the company continues to improve its technology, expand production, and successfully deliver large-scale projects, iron-air batteries could become a key part of the future energy system, helping make renewable electricity more reliable, affordable, and available whenever it is needed. This is the kind of breakthrough infrastructure we cover at Apex Engineering. We have also covered gravity batteries and liquid air energy storage. Links are on screen now. Which long-duration technology do you think wins? Let us know below. Subscribe if you want to understand the mega projects shaping the future of energy. See you in the next one.